Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video tutorial, I'm going to explain you basic rules for assembly language, assembly to machine code conversion for 86 processors. Uh, I have taken a sample format from a book, which I will be describing in the description, so you can check the book name. And from the same book, I have also taken this calculation, effective address calculation table. So these two things are required. You need the format of the instruction, which I have taken from the book, and also this effective address calculation. These two tables are required. So we have to follow this format. So if we check the format, very first thing in very first byte has three component. Let me write it. Byte 1 holds three component. First thing is called opcode, which will be given as number of bits. In this format, it is equal to 6 bits and it is given. And if you closely look at, it is basically equal to 1000010, 1000010. And the next thing in the first byte is D bit. D bit is also known as destination bit. I'm going to explain you how you can decide this destination bit, but it is equal to 1 bit. Okay. The next thing is W bit in the first byte, which is basically size of operation. Okay, I will explain what is it and how you can decide it, but it is again a bit, which means it will be one value, either 1 or 0. Then there is a next byte, byte 2. Byte 2 holds three fields, mod, reg, r/m. Okay, I hope you can see over here, mod, reg, r/m. So these three things are there. Mod itself is of 2-bit. One can see as well, 7th and 6th bit is there for byte 2. Then reg for 3-bit, and then r/m for 3-bit. And then there is a displacement low and then displacement high. I'm going to tell you how you can convert it by taking one example over here. We will take an example of this instruction. If this instruction is about move register to register, or memory to register, or memory from register. So there can be three different examples of this instruction. I'm going to take one of them. So let's say my instruction is move AX comma certain memory. Or we can take the very basic instruction, which is move AX comma BX. So first of all, first thing that you will do is opcode. Opcode is given in the format, which is 1000010. So I will simply write 1000010. Then we will decide D bit, but before we decide D bit, we need to choose the register operand. So if you look at the instruction, you have two operands, AX comma BX. So AX is also a register, BX is also a register. In that case, when both these operands are registered, then you choose what destination register. So destination is basically what AX, and source is what BX. So I'm going to choose destination. So register field is what AX. Okay, let me write in. Okay, let me write in the next line because it is all about byte 2. So register is AX, and since AX is chosen, which is destination bit, so D will become 1. For example, if it was the case, move some square bracket, which indicates some memory, then PX. Now, if I ask you out of these two, which of them is basically register, so you will say, of course, BX is a register because a square bracket is what? Memory. So we will have to choose. We don't have an option available. So we will choose BX as a register. So register field would be what? BX. But since BX is a source, so D will become what? 0. So D value, okay, D will be equals to 1 if reg is source, sorry, if reg is destination. And similarly, D will be 0 if reg will be what? Source. So in this case, so this is the rule of D. Let me copy it and paste it here. And let me delete it. So this is the rule of dbit. So since reg is equal to ax in our example, we have chosen ax as a reg, which is basically what? Destination. So d will become what? 1. Next thing is W. W is a size of operation. Okay, size of operation. Size of operation means how many bytes are being affected with the effect of this instruction. So this instruction is what? Move. You are going to move certain byte. So if you look at the source, it is 16-bit register. AX is a 16-bit register. That means you are moving 16 bits. So that means size of operation is 16 bits. So W will be 1. Okay, I'm going to write it. W will be 1 for 16-bit and W will be 0 for 8-bit. So this is the rule for what? W. Let me copy it and also paste upward. So now I'm going to talk about what W is what? 1 here. In this instruction, if you see both of these register are what? 16 bits. So W will be 1. So at this point, one can say that your byte 1 is complete. That is all about byte 1. Byte 1 is completed. Now we will talk about byte 2. Byte 2, okay? The earlier what we have done so far was about byte 1. And register field is basically part of what? Byte 2. So byte 2. So very first thing in the byte is basically what? Mod. So let's talk about mod. What is mod? Mod is 2-bit field. Okay, there will be 2 bits. So their combination can be 00, 01, 10, or 11. So these 4 options are possible. Okay, if you look at this table, you can understand these are already given. So if you look at over here, this is the mod equals to 11. And then this column is about mod equal to 0, 0. This is for mod equal to 0, 1. And this column is for mod equals to 1, 0. And how one can decide that mode value? You will have to look at your operands. So in this specific example, what we see, both of these operands are what? Register. So it's we are talking about mod equals to 1, 1 because mod equals to 1, 1 means both operands are registered. Okay, then we come to the mod equals to 0, 0. Mod equals to 0, 0 means one of the operand is a memory mod, but with no displacement. Mod equals to 0, 1 means memory mod with 8-bit displacement. Mod equals to 1, 1 is memory mod with 16-bit displacement. So what are those actually? Let me show you the example so that you understand. Let's say I'm going to write move, let's say certain memory, comma, certain memory. This square bracket indicates a memory, comma AX. So if you look at in this example, okay, in this example, if you look at, uh, you see that this is simply a square bracket, which indicate it is a memory. We don't see any displacement over here. For displacement, it will be what? It will be something like that. Move certain square bracket plus certain value. Let's say I'm going to write 24 hex. 24 hex is a 8-bit value. Okay. So this is a 8-bit displacement, comma AX. So similarly, if I'm going to talk about 16-bit displacement, that means memory mode plus some 16-bit, that means 2436 hex. Now you see that these are 4 hexadecimal digit. Every hexadecimal digit is equal to 4 bit. So these are what? 16 bit, comma AX. So I have just given you 3 different versions of same instruction. In the first instruction, you see only memory board. There is no displacement. In the second one, there is a memory mode plus 8-bit displacement. And in the third example, memory mode plus 16-bit displacement. So you don't need to write, you don't need to claim it, or you don't need to memorize it, okay? It is actually given over here in this table. If you look at carefully, you will see that this is mod equals to 1, 1. And if you look at, you see all these are what? Registers. And if you look at the mod equals to 0, so what do you see in there are only what? There are only what? Square brackets. But if you look at mod equals to 0, 1, so if you look at mod equals to 0, 0, you see only brackets. Bx is in the bracket, Si is in the bracket, base pointer is in the bracket, Di is in the bracket. All of these are in the brackets. But if you look at mod equal to 0, 1, which is a third column, you see bracket plus bracket, but plus D8. D8 means 8-bit displacement. So this column is for 8-bit displacement. And the fourth one, mod equals to 1, 0, which means if you look at every entry has D16. D16 means 16-bit displacement. So if I ask you, what about this instruction? So this is very simple. This instruction does not has any memory mode. So we will not follow mod equal to 0 because it is about memory mode. We will also not follow mod equal to 0, 1 because it is memory mode with displacement, 8-bit displacement. And we will also not follow mod equal to 1, 0 because these are brackets plus displacement. So again, this is a memory with 16-bit displacement, but mod equal to 1, 1, it does not have any bracket, which means we are going to follow this mode, and this is a register mode. If you have been following my tutorials about 8086 processor, so in assembly addressing modes, we have discussed that whenever all of the operands are register operands, then we call it register mode. So which of these 4 options we will choose? We will choose the first one, mod equals to 1, 1, because both of these are registers. So mod field is decided. Okay. So in byte 2, mod field is 1, 1. I hope you get it. Mod field is 1, 1 because of register mode. Now, the next thing that I'm going to decide is what REG is already decided. If you look at REG, when we were deciding the D bit, we have already decided. Now we just need to convert it into binary. And how you can do it? Once you know the mod equals to what? 1, 1, right? So we will go in this table, in this first column, mod equals to 1, 1. And in first column, we will check. We are talking about W equals to 1. Okay, because size of operation was W equals to 1. We have already decided it. And in that, we go to what? AX. And AX is equals to what? 000. I hope you can see that. Let me repeat. Mod equals to 1, 1. We have just decided it is a register mode. Then we go for W equals to 1. It is a W equals to 1 case for this instruction. So W equals to 1, we look for our register, which is AX. So if you find AX, AX is equals to what? 000. So what you're gonna write, the equivalent binary form of AX is 000. Now, last thing which is remaining in this byte 2 is r/m. R/m indicates the register slash memory. So if I talk about this instruction, in this instruction, we have only register. One register is already coded, which is AX. So next register which is remaining is BX. So r/m field will become equal to what? Register, because it can be either register or memory. But in this specific example, it will be what? BX. And BX, to find the value of bx, we will go again back to the table, and in mode equals to 1 1, w equals to 1, and we will look for what? Bx. So bx is equals to what? 0 1 1. Let me repeat, mode is 1 1. In mode 1 1, we will choose what? W equals to 1, and we will look for what? Bx equal to bx, and bx is what? Equal to 0 1 1. So that means the value of bx would be what? 0 1 1. One thing I still need to do to rearrange these terms mod by reg and r/m as per the given format. So if you look at the format, first thing is mod, then reg, then r/m. So I'm going to write these terms in the order. So byte 2, the first thing which we will decode is mod, which value is, and its value is decided is 1 1. Then reg, which is equal to ax, and its value was 000. And then r/m, which was basically bx, and its value was decided 0 1 1. So I'm just gonna delete it, and this is our byte 2. Next thing, we will decide what is the byte 3 and byte 4. So byte 3 is basically what? Displacement low. Since this instruction is all about register mode, okay, this instruction is all about register mode, so there is no memory. So if there is no memory, so we won't have any displacement. So displacement low and displacement high would not be considered in this case. In the next example, in the next video, I will do some conversion for memory mode, and you will see how you can actually use these two bytes. Okay, so for this instruction, our conversion is complete. It will be only byte 1 and byte 2 because there is no need for displacement low and displacement high. So if I'm going to write in binary byte 1 comma byte 2, I'm just going to write it in binary format, whatever we have coded. The first thing is basically opcode. Opcode is 1 0 0 0 1 0, then D bit 1, then W bit 1. Since if you are looking at, these are already decided, I'm just putting their values. Then mod field is 1 1, then reg, which is 0 0 0, then r/m, which is 0 1 1. So if somebody asks you in the binary, it's already converted. If you look at the literature, you will find it that usually machine code is displayed in hexadecimal form. So for hexadecimal, we will convert them into group of 4 bits. Okay. So first thing we will decide from here, it will be was 1 0 0 0, then 1 0 1 1, then the next group will be what? 1 1 00, and next group will be what? 00 1 1, and then you can simply convert them into hexadecimal format. The first thing is what? 1 0 0 0, which is basically 8. 1 0 1 1, which is basically 11. 11 is shown as B. Then 1 1 0 0, which means 12. 12 is considered as what? C. And then the last one is 00 1 1, which is basically 3. Okay, and it is in hexadecimal format. So this is also equivalent form of our instruction. This is our assembly instruction that we converted, and this is the hexa equivalent form, and this is the binary equivalent form. I hope you get it. That's how you actually convert an assembly instruction into binary or hexadecimal. I hope you have understood today what we have done. We have started the rules for assembly to machine code conversion, and we try to convert assembly instruction into its binary or hexadecimal equivalent, right? So I hope you have understand this procedure. Still, if you have any confusion, you can post your queries in comment section. Thank you so much for listening.